Here the derivative y prime is 15x squared minus 2x over 5 plus 3. Here y prime is x7 minus x4 plus 1. Pi being a constant differentiates to 0. Whenever you want to differentiate stuff involving root signs, you first rewrite your function without it. Now the half jumps down, the new exponent is 1 less than before, and ideally you write your answer as 1 over 2 times the square root of x. Similarly here, fx is actually x to the power of 1/3, therefore f prime x, which we write out, becomes 1/3 times x to the power of negative 2/3, or in other words, 1 over 3 times the cube root of x squared. Here we want to write this as x to the power of something. The power here is 3 plus 1/3, so in total it's a product of 10/3 number of tens, hence f prime x is 10/3 times x to the power of 7/3. Similarly, we first rewrite our function as x to the power of 1/2 divided by 2. So hence f prime x is x to the power of 1/4 minus 1/2 over 4. Or if you like, 1 over 4 times the square root of x. Here, instead of using the quotient rule, it's much quicker to first rewrite your function like this, because then we immediately see that the derivative g prime x is minus 4x to the power of minus 2, 1 less than before, minus 3 times x to the power of minus 4, or you can also of course write your answer like this. Similarly here you first rewrite your function so that you have x to the power of something, because then you have this neat result that during differentiation the exponent jumps down and the new exponent is 1 less than before. To differentiate this one, we view x4 plus 7 plus 8 over x as the inner function and use the chain rule. So inside your head you have something to the power of 5, and so if you differentiate that then by the chain rule you get 5 times x4 plus 7 plus 8 over x, now all to the power of 4, and as always in the chain rule you multiply by the derivative of the inner function, which in this case is 4x3 minus 8 over x squared. Similarly, here you have something to the power of 4 if you view x plus e as the inner function. So the derivative will be 4 times x plus e to the power of 3 multiplied by the inner derivative 1. Please write out the multiplication by 1. E to the power of x, you should know by heart that the derivative of e to the power of x is itself. Then, using that and the chain rule, you can differentiate e to the power of any old expression. You just, for example this one, you view 7x as the inner function and use the chain rule. So you get e to the power of 7x differentiated, that becomes e to the power of 7x times the inner function differentiated. So you get a factor of 7 popping up there. Here the story is similar. We view x4 plus 2x plus 9 as the inner function and use the chain rule. So inside your head you have e to the power of something. The derivative of y prime here becomes e to the power of x4 plus 2x plus 9 multiplied by all of 4x3 plus 2. Note the brackets. Here, instead of using the quotient rule, it's much neater to spot that this is actually e to the power of minus 12x, and hence by the chain rule, if you differentiate that, you get e to the power of minus 12x times the inner derivative, so you get minus 12 copies of e to the power of minus 12x. Same story. You have e to the power of something, so y prime, the derivative, becomes e to the power of this inner function multiplied by the inner function's derivative, which is minus 2 plus 9 over x squared. So to differentiate 9 over x, you view it as 9 times x to the power of minus 1. And then the minus 1 jumps down, the new x power is minus 2. To differentiate an exponential function where the base is not e, you first rewrite your function so that the base is e. So how many e's is 10 a product of? Well, ln 10 number of e's. By definition, basically ln of 10 is the number of e's that 10 is a product of. So our function can be rewritten using a base of e. Now ln 10 is a number, so we can differentiate this in exactly the same way as we did with e to the power of 7x. We just get a factor of ln 10 popping up from the inner derivative in the chain rule, and so this guy can be more neatly written as 10 to the power of x, because if that is that, then that is that. Ln x differentiates to 1 over x, that you should know by heart. So we just need to use the chain rule to differentiate ln of something. This is the inner function, you use the chain rule, so you get 1 over something times the derivative of the inner function. So y prime is 1 over x. Same thing, this is your inner function, you use the chain rule, so y prime is 1 over the inner function, and then you multiply by all of the inner function's derivative. Same story again. ln 3 plus x, if you differentiate it, so prime symbol indicates differentiation, you get 1 over 3 plus x times 1. Please write out times 1. Here, same thing, this is your inner function, you have ln of something inside your head, so the derivative is 1 over 3 plus e to the power of 2x, and the derivative of this inner function you probably know by now by heart, it's 2 times e to the power of 2x. Here we have a product, there is a hidden multiplication sign, so we use the product rule. You take the first function's derivative, 2x plus 1, times the second function, plus the third function, times the second function's derivative. Please write out all brackets, and you can work that out. Alternatively, you could have solved this by noting that your function is like a plus b times a minus b, and that's a squared plus minus b squared, and yeah. Here you have a product again. Please do note hidden multiplication signs. So by the product rule, the derivative is the first function's derivative times the second function plus the third function times the second function's derivative. Same thing here. Again, I stress the importance of using the product rule to differentiate products. You get 4x3 times ex plus x4 times ex. The difficult part is to spot that you need to use the product rule. Again, we have a hidden multiplication sign, so we get the first function's derivative times the second function plus the first function times the second function's derivative, which by the chain rule is 1 over the inner function, the something, times the inner function's derivative. Again, you have a multiplication sign that's hidden, so you get 4t3. Of course, here differentiation is done with respect to t, because that t has taken the role of x. Here you have a quotient, so you need to use the quotient rule. So y prime is a quotient, where you have the top function's derivative times the bottom function minus the top function times the bottom function's derivative, and then you divide by the square of the bottom function. Same thing. So to find f prime x the derivative, you use the quotient rule. You take the top function's derivative to differentiate 2x plus 1 all to the power 3. You view 2x plus 3 as the inner function. You have something to the power of 3 and use the chain rule. So you get 3 times something now to the power of 2 multiplied by the inner function's derivative. So that's the derivative of top. Then you multiply by the bottom function. Then you have minus the top function times the derivative of the bottom function. To differentiate the bottom function, we could use the chain rule, viewing x plus 7 as the inner function, so you have something to the power of 2. So you get 2 times something now to the power of 1 multiplied by the inner function's derivative. And again, please write out times 1, so that I know that you use the chain rule, and we divide by the bottom function squared. Again, to find L prime t, the derivative of L with respect to t, we use the quotient rule. So you get the top function's derivative, which we basically saw in the previous example, was 3 times the inner function to the power of 2 times the inner function's derivative, and then times the bottom function minus the top function times the bottom function differentiated. So we got the inner derivative there from the chain rule, and then we divide by the bottom function squared. And sure, you can cancel out and simplify stuff, but yeah. To differentiate this one, you use the chain rule. It really screams, please use the chain rule. So you have something to the power of 5. The derivative is 5 times this inner function, the something to the power of 4. That's the outer derivative, and then you multiply by the inner function's derivative. And please write out the brackets. Next, we will find the derivative of this derivative. It's a product, so we use the product rule. To differentiate the first function, you of course use the chain rule. So you get 20 times x squared plus 7x plus 9 all to the power of 3 multiplied by, within brackets of course, the inner derivative. And then, as in the product rule, you multiply by the second function, and then it's plus the first function as it stands times the second function's derivative. This is a different function, that's why it's important to put out the brackets. You can compare with how 2 times 3 plus 1 is 7, whereas 2 times all of 3 plus 1 is 8. Anyway, here we have a product, so we use the product rule. So we get 20 times x squared plus 7x plus 9 to the power of 3 times the inner derivative times the second function plus the first function as it stands times the second function derivative. And the 7, a constant on its own, becomes 0.